So I'm going to be talking about BGP today. BGP is, of course, the Border Gateway Protocol. I've integrated that with a little bit of a database as well. I've actually got online slides. They play on your phone and whatnot, and then there's a PDF too if you don't like the JavaScript. I also wrote a BGP logging daemon for this talk, and the GitHub project is listed for that at the bottom as well. I'd encourage you to contribute if that's your sort of thing. So who am I? Shut up! So you're probably wondering who this long-haired hippie up here is. I haven't cut my hair since the last BSides. So I'm a network architect at Daemon Defense Systems. I'm an avid open source guy. Try to contribute as often as I can. Most often that's in documentation fixes and whatnot, but I have contributed a little code here and there too. I have a new form of addiction that hasn't been studied yet, Border Gateway Protocol. I'm absolutely obsessed with network monitoring and routing, and I usually write about that on my site at ciscodude.net. I'm involved in several not-for-profits in Winnipeg. I'm on the board of directors at the Manitoba Internet Exchange, and more recently, I'm also on the board at ColdHack. If you're wondering who that is because you've never heard of it, ColdHack's a not-for-profit dedicated to furthering privacy, security, and freedom of speech. We run a handful, I think about 7, Tor Relays and exits. And we also produce Cold Kernel, which is a GRSec-enabled kernel for Debian and Ubuntu systems. And I've got a plug. So if you have extra bandwidth and or IP space to spare and you'd like to contribute to running a relay, we'd be happy to run and or manage that for you. And you can contact us through our website or through Twitter. So the inspiration, so why did I even want to talk about this? So I talked a little bit about BGP hijacking in my previous talk at BSides 2013. 2 days after BSides Winnipeg, Dyn Research put out a blog called Targeted Internet Traffic Misdirection. And this was about traffic flowing through Iceland and parts of Russia before coming back to you. It's a pretty interesting read. If you're interested in reading the article, you can visit my slides and just click through the link. Earlier this year, there was also an article about UK traffic being directed through the Ukraine. That was actually the UK, they're in charge of nuclear stuff, so it's not good, right? I can't remember exactly who it was. I'm a big fan of the BGPmon service and BGP stream. I'm actually friends with the guy who runs the two of them. So a little bit more on BGPmon and BGP stream. So in August, I saw this tweet come up on my Twitter feed, and I was like, this looks pretty interesting. So I retweeted it and several other tweets. And by the time I got to the 5th tweet, the guy contacted me directly and said, like, hey, I know who you are. Like, this is pretty interesting stuff. Do you want to chat more? It actually led to a job interview that I totally bombed, but it was a good conversation, right? So I got a link to the tweet there and the BGP stream. They actually show how these routes propagated. And it was really cool because it's Blizzard Entertainment. However, doing some research for this presentation, it turns out that it was actually a false positive. The AS number there, 16215 Alton Parkway, is actually the address of Blizzard. And that's an AS number that they'd registered in like a different region, so it got a totally different name. So it wasn't even a hijack, it was just they moved some IP space from one AS to another. So unfortunately, not as exciting as one would have hoped. But this got me thinking, was I affected by this? And other hijacks. So I got this idea, I should maybe write a BGP route logging daemon and see what can I see with this. So I wanted to log updates from various Manitoban sources. Having done a little bit of research into this before, exabgp was a Python project that seemed like a good starting place. And there was even the mailing list post with a simple shell collecting script. It was like 4 lines of shell and basically it concatenated to a file each route update that came in. I also wanted to examine peering relationships between Manitoban ASNs. Is our traffic flowing, through the states or not, or taking longer paths than necessary? And I wanted to look at the effects of BGP leaks on Manitoban routing as well. So some of the components, as I mentioned, exabgp, so that's the BGP and the Python from the topic. So I decided I was going to go with one process per address family per peer. So if I was peering with, say, less.net, I'd peer twice, once for IPv4, once for IPv6. exabgp outputs the BGP updates directly as JSON objects, and it's really quite a nice format, which leads right into the next part. How do you store this stuff? Well, CouchDB deals with JSON directly. I decided to go with one database per peer. I don't know if that was the best idea or not, but CouchDB replication makes that pretty easy to combine them all into one. And, replicate each peer. It also makes it really easy to replicate it to an offsite source, should I have a VM issue or whatnot. So building it. So I used exabgp. So there's a config file format for it. It doesn't look like Cisco or anything you're really accustomed to. It's kind of I don't know, it's a different looking format anyways. So it's got sections for route input and output. I'm not doing any route output. I'm not advertising anything in this case. All I'm doing is accepting routes, all routes, and logging them. And you can have either a Python script or you can call external things. I tried to call a Python script, but I was having trouble reading line by line instead of byte by byte. So I just left it with the bash script. It's probably a hack job, but it does the trick for now. If somebody has a better way, you can totally contribute it for sure. So it just posts those directly to the CouchDB. So I started writing this project and I called it exabgp-logger. So I was able to run it without a peer just to check that the config actually worked. And then I was like, all right, well, I'm at the point where I need to start peering with people. So I paired with my work at the time, which was MFNERC, Manitoba First Nations Education Resource Center. And I did a little bit of alpha testing. And after 8 days on IPv4 only, I had 1 million updates logged. Now, one of the things that I found was that an update can contain multiple prefixes, announces, and withdraws. So just because there's 1 million records in there doesn't mean that there was 1 million routes received. There's probably more like 3 or 5 or something crazy like that. Like I actually have on the beautiful JSON link there, it links to an example of one that is, it's about this long. It's got announces, it's got withdraws. And the first version of this script, it didn't export it directly to CouchDB. It was just outputting it right to the flat file. So I was using the script directly from the mailing list that I referenced on the previous slides. And even before I got started, I started to hit some growing pains. The stuff gets big fast, really big, very fast. So before I got too deep into this, I wanted to figure out, what would somebody use this for? So of course, there's my use case, personal interest. I'm interested in routing. Perhaps, as an enterprise running BGP or an internet provider running BGP, you'd like to know, did I accept any weird routes? And then correlate that with like net flow traffic or whatnot. Another use case is also for an internet exchange point, just to log all the route updates that are actually announced, so you can see if people are doing weird things. I've seen that mentioned in the rules for several internet exchanges, so I'm guessing there must be other people that have done this, but I wasn't able to actually find any BGP logging daemons, so I went out and wrote my own. So peering. So on September 7th, I think it was about noon, it was a slow day at work, that was my first peer. I peered with MFNERC, and I peered with them for about a week just to get some data. And then I was leaving that job on October the 16th. So you'll see a big flurry of activity in October there. So the Monday of that week, I bugged Jared, and he set up peering for me at Merlin on both V4 and V6, as you'll see. There's about a half an hour delay in there as we made sure everything was working, adjusted hold timers, all those types of things. And then several days later, I got peered to 3T Systems, who's an ISP out in Niverville. And as you can see, I peered with both of those within a matter of 16 or 30 seconds. No, that's about a minute and a half, I guess. And then a couple days later after that, I peered with Les. And then just at the beginning of November, I peered with Swift High Speed as well. So I've got I've got 4 peers because MFNERC didn't stay peered. They didn't see the value of that. And most of them are V4 and V6. So I did a little look at the Manitoban routing. Interestingly enough, there's really only 6 carriers that connect most of the ASNs in Manitoba. So Shaw, Hurricane Electric, MTS, MRNet, Voy Networks, and Les.net. So there's a lot of local interconnections between those ASs, but there's also, depending on which direction you're going, you may have to go through Calgary or Toronto or Chicago. Those are the most common interconnection points after that. There's a couple other BGP enterprises running BGP that get like a layer 2 transport directly to Toronto or Alberta or Calgary and pick up various carriers there. So scaling up. So I mentioned I had some growing pains. So the first thing I had to do is move a VM because I was leaving a job. And then when Jared set me up the VM, he said, well, this is outside of our infrastructure. This isn't backed up, so make sure you back it up. So I had to set up offsite replication, which with CouchDB was quite easy. And then I started hitting a little bit of growing pains in terms of memory usage and whatnot. So we reset up a new VM, made it 64-bit, gave it 24 gigs of RAM, 4 terabytes of space, went really overboard. I did a little look into the processes last night, and CouchDB is using about 16 of 24 gigs of RAM. And each exabgp process, so there's 7 of those, each one of those is using about 55 megs of memory. So that's not bad, actually. I expected more memory on the exabgp side, but that wasn't the case. So here's some screenshots of the database size. So this screenshot was taken last night. I looked again this morning, and there was over 17 million records now. This is like 16.8 at the time. The size of the database goes up and down depending on whether you've compacted it or not. The replication seems really efficient, but just writing directly, it can use a lot of space. If I was to compress that, I could probably get that down to 8 gigs or something like that. So as you can see, I have a database for each peer directly, and then I have a combined one called BGP-log. Now the problem is when I'm looking for something, if I need to make a new index, running that through 16 million records can take a long time. So I'll probably start on one of the smaller ones. If I'm looking for something historic, I'd probably look at the MFNERC one because there's only 1 million records. And if I'm looking for something live, like I did this morning, then I look in the Swift one just because there's only 1.4 million records. And the database has been using between 20 and 40 gigs of space, depending on if I've run compaction or not as well. So finding events. So currently, I've made a query, like a CouchDB view, to search for AS paths, because that was mostly what I was looking for. When a new AS starts advertising something, I'm able to find that fairly easily. It can take a while to make the indexes, though, especially on the 16 million record DB or 17 million record DB. And I've validated several events from BGP stream. And I found that searching by the prefix was not very efficient due to lack of CIDR search abilities in JavaScript. I'm thinking I might actually, in the long term, end up using CouchDB as the collector and then following this handy-dandy underscore changes table and populating a route, an actual routing table right from there. And I actually, this morning, I didn't have time to put it in my slides because I didn't feel like running make again, but I actually captured I'm just going to go over here to another tab. So this is a tweet this morning from BGP Stream. This is an IP space from a company in Great Britain, and it was hijacked by an airport in Iraq. And upon further, so I was able to validate this. So this is the actual data for that, and it's probably really tiny from there, but I can make the font size a little bit bigger. So if I go in and I look here, I'll see that in this particular announcement, I see, oh crap. I see the prefix that was mentioned in the tweet, so 85.118.8.0/24, and then another one, which was mentioned in the subsequent tweet, 85.118.9.0. But if I scroll down, keep scrolling. If I scroll down, I'll see, oh, there was actually other IP space that wasn't even mentioned in that tweet. So 85.118.10 and 11.0/24 were also hijacked as well. So I'm able to easily correlate events that have happened and validate that, okay, I actually did see this. So automating this. So one of the problems is that I have this giant haystack of data, but when an event happens, I don't get notified about it. And so to solve that problem, I did a bunch of thinking, and I chatted with some of my buddies about this. And basically what I discovered I needed to do is actually create a routing information base for each peer so that when new advertisements come in, I can compare this and say, is this something I've seen before? Is this new? Is this coming from a different location than it has in the past? So I need to be able to compare prefix length and AS path. And something that would be really handy would be the ability to replay these JSON BGP updates from the CouchDB directly to a real router. And I've actually seen requests or tools like this on the North American Network Operator Group list before. So I might be able to get some actual users if I went out and wrote this tool. And one of the big things is false positives. So every time that BGP Stream tweets about something interesting, I'll go look into it, and more often than not, it's like the BGP hijack, or the Blizzard hijack, where it wasn't actually a hijack, it was a different division of the company registered in some other part of the world or something silly like that, or a DDoS protection service. Lots of false positives. In fact, this one that we're looking at this morning could be a false positive. This Iraqi airport could be leasing IP space from this Great Britain provider. Who knows? I mean, we don't know what the business relationship there is. So I just wanted to say thanks as well to Merlin, especially Jared and his management team who supported the project. They also had a really nice just note of support on the tech list that I had posted this on. 3T Systems, Jordan, offered to peer right away. Was able to contact him and got peering set up for both address families, and well, you saw in a matter of minutes. Les.net, both Les and Jonathan both supported the idea and made peering happen. And Swift High Speed as well peered, and thank Evan for that. And also BSides for inviting me to talk about this again. So is there, we got time for some questions, I'm pretty sure. 5 minutes? All right. The hand in the back? Oh, hey, I know you. Not really. Because of the way that more specific routes work, you can't just send traffic unless you had a private interconnection. And the whole internet doesn't have a private interconnection, so it wouldn't really work that way.
Another one for you. Are you seeing ASs announce changes on only one address family if they have two? Or similar, like brain dead jump like that?
I haven't got the code together to make a nice interface to view changes like that yet, but I'd be curious. You'd probably be able to line up like outages, you know, with a V4 and a V6 announcement later on, or withdrawal. The way that withdrawals work in this is it's pretty ugly actually. All you get is this prefix was withdrawn. So you now have to go back into your list of prefixes that you're keeping track of and match that up with an AS path and the whole original announcement and then pull that out of your list. It's actually pretty amazing how it works.
What are you going to do for the next BSides?
I don't know. I'm not sure. It might be a follow-up in which I actually have some nice graphs on this, or...
I was going to ask, what are your next steps? What is the data you're trying to get at, ideally?
Ideally, I'd like to be able to automatically detect prefix hijacks and new announcements. And then, obviously, they have to be filtered by a human because most of them are going to be false positives or things like that. But I'd like to be able to figure out, like, okay, so I maintain on my ciscodude.net website, I maintain a list of all the Manitoban AS numbers, like everybody who's running BGP. And so I'd like to be able to detect when, you know, like I have a list of people that aren't running BGP but have an AS number. I'd like to know when do they go live. And with this data, I'd be able to see that. And then also, like, when maybe you have a /22 of IP space and for whatever reason you decide you're going to advertise some more specific routes for traffic engineering, it'd be nice to get notifications of stuff like that too. Any other questions? Oh.
Yeah, you were talking about interesting events on V4 there. Do you have anything on V6? Is it still a research network or real live events occurring?
There's events happening. Like I've seen some prefix hijacks on BGP stream. So there is some stuff happening there, but it's like 1 in every 200 tweets or something are about V6. They're mostly about V4. But I mean, there's a handful of routes only on V6 as compared to V4. Like I don't know the exact number of routes these days, but it's probably about like 20,000 IPv6 routes compared to 550,000 IPv4. Yeah, exactly. And with V6, you're supposed to get bigger allocations, so you can just advertise a big giant summary route, and hopefully things should be more stable. I mean, that's what they were intending anyways. John?
Random stupid idea for you. If you're keeping track of your updates for a long period of time, or even short period of time, combine that with geolocation, and you can make a pretty picture of your perimeter shape of the internet.
Mm-hmm.
That would be a conflict.
Yep. No, definitely there's some neat visualizations and stuff that I could do with this data.
Do you make your data available?
I don't know. I mean, it's an absolutely huge chunk of data. I don't know that it's useful to anybody yet, but I'd have to talk with the people who are supplying it to make sure that that would be okay. But if everybody's cool with it, I'd definitely be willing in sharing it. I think that's about it.